Right, we are talking about 5-1, which is rate of change and slope today. There are two vocab words. If you would pause your video, do your heading and your vocab, and then come on back. Our first vocab word is rate of change. Our second is slope. So rate of change and slope end up actually being the same thing. We're talking about graphs. And we're talking about how much those graphs change as we go along the line. So when you think about rate of change, it is the change in the dependent variable over the change in the independent variable. So our independent variable is our x, that's what we're putting in to our equation. Our dependent variable is our y, that's what's coming out of the equation. So rate of change is how much does it go up over how much does it go over. You're always going to go over to the right, okay? And you're going to start at your point that is on your y-axis, and then you'll figure out how much do you go up, or you could be going down if your line is sloped that way. So you're going to start wherever your line hits the y-axis, count up, and then over. So it's up and then over to the right. That's going to be your rate of change, which is also your slope. Okay, slope we say is the vertical change over the horizontal change. And again, I always want you to start at that point where it touches the y-axis, and then you're either going to go up or you might have to go down, and then you're going to go to the right. Don't go left, go just to the right to count that change. When you look at problem one says finding the rate of change using a table. So they, in problem one, are giving you some order pairs, some x's and y's, and you are going to find the rate of change. So the table gives us these order pairs. We're going to take two of those order pairs, and it doesn't matter which two you choose to use. Any two, as long as this is a linear function, any two are going to give you the same rate of change. So you can see they've actually done different order pairs. In the example here, they've done 3 different order pairs, and they always come up with the same rate of change, which is 260 over 1. So they go 260 feet in 1 minute. And that rate of change is constant over the entire distance marched. If you look at the got it, so got it 1, it says in problem 1, do you get the same rate of change if you use non-consecutive rows in the table? So for problem 1, they've only used consecutive order pairs. So they tried 520 minus 260. And then for the bottom, you would have 2 minus 1. So they have done that and gotten 260 over 1. So now they're asking, well, what happens if you use non-consecutive numbers? So what if we start with 780 for our first number rather than 520? Excuse me. When we subtract here, we will get 520 over 2. If you reduce this, so we're going to divide both by 2, because that is our greatest common factor, you will actually end up with what we had previously. So although these are non-consecutive, once you do the math and you reduce it, you will end up with the same rate of change. Moving on to our slope questions. At first, they're going to give you a graph, and they want you to look at that graph and decide whether or not, or what, I'm sorry, decide what. To do that, like I was saying, you're gonna look at where your line is going to hit. I really wish I had my graph with me. You're looking at where your line is going to hit on one of these crosshairs. So where the vertical and the horizontal lines meet. Find a spot where your line hits one of those intersections. So this line is hitting here and here. When you look at this, then you're going to start at this point and you're going to go up 1, 2, and then you go over 1, 2. So the slope here, and we write slope as an M. So you can say slope or you can say M equals 2 over 2, which of course reduces to 1. So our slope here would be a 1. They've also shown us some negative slopes. So remember I said you're going to start and you're going to go up and then to the right. If your line happens to look like this, so it's going downhill from left to right, you're going to have a negative slope. So we're going to look for those spots where our line hits the crosshairs again. In this case, we're going to have to go down. So we go down 1, 2. So our top number is 2. And then we count from there, how far are we going to the right? So we go right 1, 2, 3. That's our denominator. And this slope would be negative because it is going downhill. If your slope or your line is going uphill, it's going to be a positive slope. If your slope is going downhill, then you have a negative slope. So we went down 2, which means we have negative 2. And then we're always going to go to the right to do this. So we go right 1, 2, 3. And our slope here is negative 2/3. Try got it 2A and B, and then come on back. When you look at got it 2A, you're going to notice in the graph that they give you that they have some red dots where your line is hitting those crosshairs. You're going to go to the red dot on the left, and then you're going to count either up or down. If you're going up, that means it is a positive slope. If you're going down, it's a negative slope. So got it 2A, we are going to go up, and we're going up 2. And then we go to the right. Let's see. 1, 2, 3, 4, 5. So we went up 2 to the right 5, so our slope would be positive 2/5. Okay. Got it to B. You see again, they have those 2 red dots for you. This time your slope or your hill is going down. You're going to slide down the hill instead of climbing up the hill. When we slide down the hill, that means our slope is negative. Again, always start at the dot on the left. In this case, you're going to go down. So we go down 1, 2, and then we go to the right 1, 2, 3, 4, 5, 6. So we will get negative 2/6, which we can reduce. And you reduce these the same as you do fractions. So we're going to divide our numerator and our denominator by 2. 2 divided by 2 would be 1. So we get negative 1/3 for our slope there. Things to keep in mind, if your slope, your line is going uphill, that's going to be a positive slope. If you are going downhill, this is going to be a negative slope. And that's very important to remember. Also remember that you can reduce these. Remember to start with your point on the left, and then you're going to count up or down, and then to the right. When you count up or down, that's giving you your numerator. When you count to the right, that's going to give you your denominator. Moving on to example 3. Example 3 shows us how to figure out what the slope is without having a graph. So they give us the slope formula, which says that slope equals rise over run, which you can also say change. Change in math is written as a triangle. So change in y over change in x. And what that looks like is you're going to take one of the y's, subtract the other y, take one of the x's and subtract the other x. When you do this, it's like so many other things in algebra. It doesn't matter which order pair you decide is going to be your x1 and your y1, or your x2 and your y2, as long as you keep it the same within an order pair. So if I have two order pairs, here we have -1, 0, and 3, -2. If I decide that these are going to be my 2's, and these are my 2's, and these are my 1's. If I decide these are going to be my 2's, that's fine, but then these have to be my 1's. So it doesn't matter which ones are your 2's, which ones are your 1's, as long as one order pair are the 2's and the other order pair are your 1's. You can't mix and match and say, well, this is going to be my x2 and this is going to be my y1. You cannot do that. You also cannot, I've seen this mistake. This one kind of drives me crazy. Sorry if it was you. But you can't decide that this is going to be your x1 and this is your x2. It's not how order pairs work. Remember on my wall in my room, it is always and forever x and then y. Always. So you can't decide that these are going to both be x's. It's not how it works. Completely illegal math move. So this is going to be an x, this is a y, this is an x, this is a y. This is an order pair, this is the other order pair. You can decide which order pair is going to be your 1 and which is going to be your 2, and that is going to make your x and your y the same number. So I'm going to decide these are my 1's, these are my 2's. Now I've decided that, I can plug them into my equation up there. I highly recommend writing that out and then plugging it in. So we've decided this is my y2, this is my y1, my x2 is 3, my x1 is -1. Now I can go ahead and do this math, and I get -2 over 4. -2 over 4 reduces to -1/2. So my slope here would be -1/2. Try got it 3 and come back and I'll solve that for you. Okay, got it 3. We have, again, two order pairs. We can decide which one are going to be our 1's and which are going to be our 2's. I'm going to make these my 2's, and I'm going to go ahead and write that right underneath. Write my 1's underneath this one. And then I'm going to write out my slope equation, plug in so this would be -4 over 3. And you can just leave it improper like that. With slope, it's easier to understand that my change in y is -4. So I'm going down 4. And my change in my x is 3. So I'm going to go down 4 over 3. It's easier to see that if you leave it an improper fraction than if you would change it into a mixed number. So just leave that -4/3. The next problem shows us a graph, and we're going to learn here about vertical and horizontal lines. So interestingly enough, we've talked about horizontal lines are functions, vertical lines are not. Clearly, though, a vertical line is a line, it's just not a function. So check out what happens with slope here. If we have, say, a horizontal line, go to 2 points on that line, right? If we're counting how far did we go up or down, we didn't go any. We didn't change our rise at all. We didn't go up or down. Our run, though, is going to change. So we're going to end up with something like 0 over 4. And what's 0 over 4? It's 0. So our slope here is 0, which makes sense. We're not going uphill, we're not going downhill, we're just staying even. So slope is about rate of change. We don't change. We just keep on going straight. With a vertical line, if you think about going from point to point here, you are going to change a lot. So say we decide that's -4. Well, what about our run then? So how far right are we going? We're not. Mathematically, what's -4 over 0? Not a real number. This is undefined. It's not real. So in this case, because that is undefined, the slope is also undefined. There's no slope. Not no slope as in 0 slope. That's a horizontal line. This one is not real. It doesn't exist. So again, those vertical lines cause problems. Okay, we knew they weren't functions because that vertical line test, it's going to fail at every single point. It also doesn't have a defined slope. Try got it 4A and got it 4B. See if you notice the excuse me, see if you notice the pattern that happens with these horizontal and vertical lines. When we look at our got it's here, we have for A, we have 4, -3, and 4, 2. And for B, we have -1, -3, and 5, -3. So notice in this one, our x's are the same. In this one, our y's are the same. Okay? So up here, it's our x's that are the same. Down here, it's our y's that are the same. If you can remember which one is horizontal and which one is vertical, it'll help you pick these out really quickly. If you see that either your x's or your y's are the same, you know it's going to be a horizontal or a vertical line. Think about how you graph these guys. So if we have 4, -3, it's going to be around there. 4, 2 would be here. So this one is our vertical line. This is undefined. You can't define a slope there. With our y's being the same, we are going to go to the right 5 and then down 3 and then the left 1 and down 3. This one is a horizontal line. The slope is going to be 0. This slope is undefined. So right away, if your x's are the same, you know your slope is undefined. If your y's are the same, you know your slope is 0. That is it for the examples here and the got it's. And they show a nice summary on page 317 of the different kinds of slopes. So if you're going uphill, you are going to have a positive slope. If you're going downhill, you're going to have a negative slope. If you're a horizontal line, your slope is 0, and if you're a vertical line, your slope is undefined. I want you to go ahead and try a few of these. Let's do 9. Let's do 6. 6 to 18 by 3s. So So you're doing 6 to 18 by 3s. These are not due until next Monday. If you get them done sooner, that's great. You can watch the review and see if you have any questions. If you do, make sure you take a note so that when we have our next Zoom session, you can ask those questions. I will see you all then.